Alright, so this video is going to help with the questions for the analysis of the commercial bleach lab. I already put some helps up on Classroom. I'm just going to kind of go over those and use the pre-lab to help with some of the calculations you have to do for that lab. The first question that you are asked to take a look at is, again, make sure you show sample calculations, follow your sig fig, rounding rules, all that good stuff, include your units. The first question asks you to look at how many moles, in theory, of the sodium biosulfite, are equivalent to 1 mole of the sodium hypochlorite. And the equations are from the introduction. What I do want you to keep in mind with this one is that the thiosulfate ions that are present in those equations are coming from the sodium thiosulfate, and it's a 1-to-1 ratio. And then the same thing for the hypochlorite ions. They are a source of ions from the sodium hypochlorite, which is the common ingredient that's active in bleach. So hypochlorite is present in equation 2, and thiosulfate is present in equation 4. We had to convert the hypochlorite ions into triiodide because that was a more effective way of determining that the titration was complete. It would not have been as effective to just titrate the bleach straight with the thiosulfate. There wouldn't have been any sort of indicator that would have told us the reaction was completed. So if we go back and look at what we did, we added potassium iodide, which was a source of iodide ions, and that turned it into iodine. We continued to add an excess of those potassium iodide ions. I added, I think, 2 grams approximately per sample that you tested, and so that turned it into triiodide when it was acidified. And so the presence of those triiodide ions reacted in a 1-to-2 ratio with the thiosulfate. So 1 to 2 for the triiodide to thiosulfate, and we see that it's a 1-to-1 ratio between the iodide and the triiodide ions in equation 3. Why that's important, we can go back to iodine. We see that that too is in a 1-to-1 ratio between iodine and triiodide, and that the iodine is what we got from the hypochlorite ions. If we look at hypochlorite, we see that there was 1 OCl minus for 1 iodine, there was 1 iodine for 1 triiodide, and there was 1 triiodide for every 2 thiosulfate ions. So hopefully that can help you kind of connect how many hypochlorite ions were needed for every 2 thiosulfates. Okay? And we were starting with 1 mole of the hypochlorite ions. Second question asks you to calculate an average. That's pretty straightforward. That's straight from your data. If you need help with that, come and see me. Number 3, it says using the average volume and molarity of the sodium thiosulfate, use that to determine the molarity of the diluted bleach. So you knew the volume and the molarity of the thiosulfate, and that should give you something when you combine those in terms of the sodium thiosulfate. Okay? We know the bleach was a source of OCl minus, and we just looked at in question 1, how you could relate OCl minus to thiosulfate. It is not a 1-to-1 ratio. You're going to have to use those equations up in question 1 to help you with that. Once you have that ratio, you should be able to use solution stoich to relate the thiosulfate to the OCl minus, which is what is the active ingredient in your bleach. And because you were trying to find the molarity of your diluted bleach, you would need to divide that by the volume that you actually titrated with in your Erlenmeyer flask. So an example of that would be from your pre-lab. So if we go back and take a look at question A for number 9 on your pre-lab, you were given a solution of vinegar that had acetic acid and water making up the mixture. You pipetted out 10 mils of the household vinegar and diluted it with water to 250 mils, and then you took 10% of that sample, 25 mils, and titrated it with 16.7 mils of 0.05 molar NaOH. So I can use the moles and the volume of NaOH, the molarity and the volume of NaOH to give me moles. And because the balanced equation shows us there's a 1-to-1 ratio between the acetic acid and the sodium hydroxide, that there would be the same number of moles of the diluted vinegar, since that's what we titrated. And because I use 25 mils in my titration, if I divide those moles of diluted vinegar by the volume, I can get the molarity of it. You're going to follow basically the same process to do the question we were just talking about. So if I go back to those, So again, that should help you with number 3. Number 4 is like 9b from your pre-lab. It says calculate the molarity of the commercial bleach before it was diluted. And I said that I wanted to remind you that I took approximately 5 mils of the bleach and diluted it to a volume of 100 mils with water. So 5 mils of the commercial bleach was used to make the new concentration of diluted bleach. And from question 3, you know the molarity of that diluted bleach, and you also know the volume of the diluted bleach that you titrated. You know how much of the commercial bleach you prepared, or excuse me, how much of the commercial bleach you used to make your solution. So we should be able to find the molarity of that commercial bleach. If that's not clear, hopefully this will help a little bit. So in 9b, it says calculate the molarity of the household vinegar, and again, dilution equation is going to help you because all we're doing is staying within vinegar. I set the 1s to be the concentrated solution, which would be the household vinegar, and 2s to be the diluted vinegar. I'm wanting to find the molarity of the household vinegar, so that was my M1. And in the reading I gave you for number 9, it says that we took 10 mils of the household vinegar and diluted it to 250 mils of the diluted vinegar. So the volume I'm putting here is not the volume I used up here in part A, it is the volume of that diluted solution I made. The concentration of that diluted solution is what I got from part A, and by dividing those by 10 mils, I get what the concentration was of my household vinegar solution. So again, if I go back and take a look at this one, I know the molarity of my diluted bleach from number 3. I know the volume of the diluted bleach I prepared. It says it right there in number 4 that you made 100 mils of it, and that you took 5 mils of the commercial bleach to prepare that 100 mils of diluted bleach. So hopefully that should be enough to help you find the molarity of the commercial bleach. Number 5 is like number 9c on your pre-lab. It says assume the density of the commercial bleach is this 1.8 grams per milliliters. We want you to calculate the percentage of the hypochlorite that was present in the bleach. And you need to make sure that you use the molarity of the commercial bleach when you do your calculations. And I told you here that the molarity of the commercial bleach is equal to the moles of NaOCl per liters of bleach. That because the percentage of NaOCl was just part of your bleach, the rest of it was water, is going to be the grams of the sodium hypochlorite that was present per gram of bleach times 100. And then you can use the density to relate the grams of the bleach to the volume of the bleach. So we want to find a way to get from this first one here to the second equation, to get from moles of NaOCl to grams of NaOCl, to get from liters of bleach to grams of bleach, and then multiply it by 100. So I think the conversion between moles and grams is pretty straightforward. The one between grams and liters, you may see that there's a connection with the density. And so I'm going to show you now is how 9c would have been done on the pre-lab. So with 9c, we knew the molarity of the household vinegar from part B, 0.835 moles per liter. I can convert moles of acetic acid to grams using the molar mass. So just like for bleach, again, you want to do the whole bleach NaOCl. I can convert liters to milliliters. Why that's important is because my density is in grams per milliliters. And the only way I have to get between a volume of my solution and the mass of it is to use density. I have to reverse it because I want to turn liters into grams, and I want the grams to be in the bottom. If you want to do this separately, you can. You would need to do the moles of acetic acid separate from the liters of vinegar, and then you would multiply times 100. And I got that there was approximately 2.7% acetic acid in household vinegar. Now there's kind of a check in place to see if you have done the calculation in number 5 correct. Again, it may not be exactly 5.7% or close to that because the bleach has been opened, it has been used previously, and it does decay over time. However, it should be in that ballpark. So if you get a percentage well over 5%, there's probably something slightly off with your calculations. Or if you get a percentage that's well below 1%, again, I would have me come take a look at it and see what's going on. but you are to use the average percent of NaOCl and what you got in number 5 to calculate the percent error. I would like you to round that to 0.1%. And then finally, number 7, it asks how these laboratory errors would have affected the calculated percentage of NaOCl. Would it have made it too high? Would it have made it too low? Would it have had no effect? And then tell me why. So the first one says that you didn't allow the blue color of the starch to completely disappear. Again, we added the blue starch, or excuse me, we added the starch to be able to determine when the reaction was complete. You kind of saw what happened when it was getting close. It was that nice little bright yellow color. And then as you added the starch, it turned to kind of a grayish, bluish, purplish color. And then over time, it went back to clear. Finally, in part B, rather than using 1 molar HCl, you used 1 molar HCl instead of 3 molar HCl to make your triiodide solution. I believe back in the introduction to your lab, it talks about what is needed in order to turn the iodine into triiodide. I would take a look here in the series of steps. It talks about how triiodide is yellow when it's dilute. I think that's kind of what you saw before you added the starch. And then it's dark red brown when it's concentrated. And you need acidified iodide to turn that iodine into triiodide. So please keep that in mind. 1 molar is obviously not as strong as 3 molar. It then also says using 5 grams of potassium iodide instead of 2 grams of potassium iodide. I use 2 grams per sample to help to get the iodine in to react with the bleach. The 2 grams was in excess, so 5 grams would have been 2.5 times that amount. I hope that helps with the lab, and if you have any more questions, please come see me.